3. What's the degree on the bottom?
3.
3. So if the degree on the top and bottom, okay, so the degree on the top is the same as the degree on the bottom. That's actually really nice. That's the nicest case you could have because you have two things that are totally dominant and nothing else matters. Everything else is descending powers. This is assuming it's cleaned up, right? If you have the same powers, what are the only two numbers that matter there? Someone figured this out. The leading coefficients, the 2 and the -5. When the degrees are the same, the leading coefficients are the only thing that matters. So what's the horizontal asymptote going to be? Oh, -2/5. This one, you also have to look at negative infinity first, but since that's cubed and that's cubed, the top and bottom are always going to have the same sign. Like if it was different, then you could run into a different thing. But look, if the top is negative, the bottom's going to be positive. If the bottom is negative, the top is going to be positive. Does that make sense, everybody? Yeah. Basically, you can think about it like this. For huge numbers, since these don't matter, you can ignore them. If I just gave you 2x cubed over -5x cubed, what cancels? The x cubes. What's the only thing left? 2 over -5. Now in this case, this would be the one where you'd ask yourself, what is the sidedness of this? On this one, I would not ask you to figure out the sidedness just by logic. I might say piece together the graph using way more information. I would not ask you for the sidedness on this one because figuring out the relative size of this and this is kind of annoying. It's not impossible. You could do it. This is where you think to yourself, you plug in a big, okay, that's going to take away from, but it gets annoying because of the signs. It's not what's important right now. Okay. Does that make sense? When the degrees are the same, you just look at the leading coefficients? Yeah. Yes, no.
So like, we'll assume that you're going to specify when you want.
I am going to specify, and if it's not clear, just raise your hand and be like, do I need to do it on this one? Okay? So what's different about this one? What's the degree on the top? 2. And what's the degree on the bottom? 1. Okay. So if the degree on the top, this is a simple rule, everybody. If the degree on the top is greater than the degree on the bottom, it's going to blow up and get huge. Right. Because as you plug in a bigger number, that square gets huge, and this one gets big too, but not anywhere as fast. Okay. So this turns into Everest, and this stays not that big. So what's huge over small? Oh, big, it's infinity. Yeah. But then when you plug in negative, when you start going negative, when you square something, what does it become? Positive. But when you plug in a negative, it becomes negative. So therefore it goes to negative infinity. So this is another rule. If the degree on the top is greater than the degree on the bottom, the end behavior is going to be either plus or minus infinity. Okay. Then similarly, let's look at the next one. I think it does it right over here. Yeah. It's the exact opposite. The degree here is greater on the denominator than on the top. So as the bottom gets huge, the top one is like muttering along. So what is a relatively small number over a huge number? What does that get close to? 0. Then you can logic out sidedness, but again, that's not what's important right now. Knowing why it's 0 is the important part. Yes?
So if the numerator is smaller than the
If the degree of the numerator is smaller than the degree of the denominator, it'll always go to 0. Always. In math, there's lots of common types of answers. 0, 1, or infinity are like super common answers. Seriously, 0, 1, or infinity. I always find the most interesting math problems are the ones, or -1, right? Yeah. I find the most interesting math problems are the ones that are like, the answer's like, here's the thing that happens in the natural world, and the answer is 17. And you're like, whoa. Those things blow my mind. Another one. So on the top, what it's asking for is, what happens as x goes towards -3 from the left? I think it's a minus sign on the first one. Can you see? From the left. So where does x equal -3? X equals -3 on this dotted line. You see it right there? That's x equals -3. So as you approach from the left, what does the function do? It spikes up. So it goes to positive infinity. As you approach -3 from the right, if you were on the function and you're approaching, the x coordinate was going towards -3 from the right, what happens? It goes down. So it's going to be negative infinity. What about this one? This is x approaches 4 from the left. What's the next one? Yeah. 4 from the left. Where's 4? This is x equals 4 right here. See x equals 4? X equals 4. You're approaching from what side? So it's going to go to negative infinity. From the right, what is it going to go to? Positive infinity. Now this is the end behavior. What happens as x goes infinitely big and what happens as x goes infinitely negative? This you can definitely tell the sidedness. Because as x gets infinitely big, what does this get infinitely close to? 1 from the top, from positive, from the top. What about negative? As x goes to negative infinity, if you're on this roller coaster, the x coordinate goes to negative infinity. As you move this way, what does the height get infinitely close to? 1 from the top. Input on the left, output on the right. Kind of makes sense? So in this case, remember what I said, it's sometimes really easy to notice the side of approach, and sometimes it's much harder. In this case, you have a picture, so you can say, oh, it's coming from the top. It's coming from the top. Okay, we ready to move on? Do these look like the same thing? They don't look like they're the same thing, right? They don't look like they're the same thing. Let's try on your calculator. If you graph them, they would look exactly the same. Anybody want to guess why? Why, Danny?
Because for the first graph,
yep.
first step of x, you can.
So if I were to do this here, what was it? It was x squared what?
It's x squared.
X squared plus 8x plus what?
15.
Plus 15.
Over
divided by what?
x plus 3.
X plus 3. And I like, let's do zoom. I don't know what the zoom is set at. Let's do zoom standard. No. What's standard? 6? Oh, what did I say? Oh, it's a line. What did you expect to see? What might you have expected to see?
Line.
No, yes, by the logic we did, but you look like some sort of curve, maybe an asymptote in there, right? But here's the thing. Is there an asymptote at least on that part of the window? You might have expected there to be an asymptote at x equals negative 3. But here's the thing. Danny just gave us the clue. What can we do with this? We can factor the top. Can someone factor the top for me other than Danny? Or Danny's just going to say it out loud. Okay. It's okay. It's okay. X plus 3 times x plus 5 all over x plus 3. Now, before we factor this, if you just looked at that function, I said to do nothing with it, could someone tell me what the domain of the circled red function is? All real numbers except what? Nope. Except what? Negative 3. Can you plug in negative 3 into the original function? No. What happens if you plug in negative 3? You get it's undefined. Can you plug in every other number? Yeah. That bar right there, you see that little bar? That means such that. So that says x such that x doesn't equal negative 3. Nice. Okay, so now we factor. I love factoring, by the way. It's like my favorite thing in the world. What can you do after you factor? You can cancel. So what does it become? But here's the thing. So when you graph it, that's why it looks like x plus 5. But what happens at x equals negative 3? Can you plug in negative 3 into this function? No. What happens there, do you think? It's a discontinuity. What kind of discontinuity? So so this is 5 right here. So it's going to be negative 3 is right about there. There's going to be a hole right there. How can you figure out the y coordinate of that hole? Nope, you don't need a limit. What's the x coordinate of the hole? What's the x coordinate? Negative 3 is the x coordinate, right? What do you plug it into? X plus 5. What's negative 3 plus 5? 2. So what's the coordinate of that hole? Oh, so this has a hole. So can you tell me, when will holes occur? When will holes occur? When you cancel. When you can cancel out a term from the denominator, you will have a hole there instead of a what? Instead of an asymptote. There is no asymptote here, there's a hole. Now, on the calculator, does it say there's a hole, by the way? Do you see a hole anywhere on this? No. Why don't you see a hole?
Because it says x plus 5.
Yeah, well what it's doing is when a calculator graphs, it actually graphs a lot of points. It doesn't graph like all the points. Because how many points are there? An infinity of them, right? So there is no, if you zoomed in, would you eventually see a hole? You'd see a little gap. The resolution is not very good on this either, and it's not programmed to tell you. I think it would be really cool if the calculator put it out there, but you have to realize calculators, these hand calculators, they're not really thinking devices. They're just algorithmic. They do, when they graph a function, they just plot, they divide, they take the window for the x values, and they do like 100 points, and then they plot the points, and it looks like a line. So you're like, oh, it's a line. Okay, factor this. Don't simplify, just factor that for me. Lauren, what does the top factor into?
X plus 4,
Like this. And someone who hasn't spoken yet, who wants to tell me? Maggie, can you factor the bottom for me? It's a little trickier.
Oh, I haven't done it yet.
Well, it's going to be 2x and x, right?
Yeah. And then,
It's going to be minus over here, I think. Maybe plus over here, like that.
yeah, plus 3.
I think it's
Plus
I think it's plus 1 and minus 3. What should you always do, even when you're really sure it's correct? Check. Please do. 2x squared plus, minus 6x. That's nice. Plus x minus 3. Does it work? Oh, it does. Before you cancel, this is where you find the domain. Can someone tell me what are the two things that x can't be? X cannot be negative half or 3. Because if you plug in either of those numbers, what happens to the denominator? It becomes 0. Now, can you cancel anything? Is there anything that cancels? It's okay to say no. No, there isn't anything that cancels. So are there going to be any holes on this one? No. Is there going to be a vertical asymptote? Yeah. How many? 2. What's one of them?
3.
And? So when I ask you for vertical asymptote, make sure you do x equals. An asymptote is a line. An asymptote is a line. So there are no holes. There's one other type of asymptote we could look for. The horizontal asymptote is the end behavior. What's the degree of the top and bottom? Are they equal? Are they different? So what is the horizontal asymptote? You got it. Just look at it. What's the horizontal asymptote? You can figure it out. That's the number. So what's the equation? Y equals 1/2. Why is it y? What the y value is? What do you do?
3 and 4x.
Plus 4 over. So that's going to be 3 plus 4 over plus 5. So that point is 3 comma 7/8. Yeah. So you know there's a hole right there. Yay. Is there a vertical asymptote? Yes. At x equals? Yes, the thing that's left. Is there a horizontal asymptote? Yeah. Y equals? 1. Now the last one is fun, the intercepts. How many types of intercepts are there?
2.
The x-intercept is when y is 0. And the y-intercept is when? Which one's generally easier to find? The y-intercept. If I plug in x equals 0 right here into that equation, x equals 0. If I plug x equals 0 in right there, you get 0 plus 4 over 0 plus 5. So what's left? 4/5. How many y-intercepts can a function have? 1. If it has more than one y-intercept, it is not a function. Doesn't pass the vertical line test. What about the x-intercept? That's fun. It's 0 equals this. How do you make a fraction equal 0? Numerator. So x plus 4 has to be what? I can almost write here, sorry. X plus 4 is 0, so x is equal to? So that's negative 4 comma 0. There are your two intercepts. Now, is that a lot of information about this? Yeah, so what you would do next is theoretically put it together and draw me a pretty picture. As limits, so that's the limit as x goes to infinity and the limit as x goes to? As x goes to? Negative infinity. These are both of the function. So what's the degree of the top and what's the degree of the bottom?
2.
So what are the only things that matter? The leading coefficients, the ones in front of the biggest, highest term. So what's the leading coefficient in the numerator? What's it on the denominator? So both of these are going to be 2. So that tells us the horizontal asymptote is what? Y equals 2. Find the domain and state the holes or asymptotes. So what do you have to do first before you find the domain? Factor. So if you factor this, what does it become, Liv? What can you pull out first on top? Yeah, pull that out first and it makes it a lot easier to factor.
So it's x minus 3, or 2x minus 3x plus 2, and then on the bottom.
X minus 3, it's 6 right there, isn't it?
Yeah.
X plus 2?
Yeah.
And on the bottom, what does it become?
X minus 5, x minus 3.
Like that?
Yeah.
So first you say, what's the domain? Can anybody tell me what that is? Can someone tell me? Yeah, Maggie.
X.
Yep. So,
Such that
yep.
X cannot equal 5 or
Exactly. Now you get to cancel, right? That cancels out. What does that tell you? Is there a hole?
Yes.
Where's the hole occur? 3. And then what do you plug 3 into? This. What's 3 plus 2? What's 3 minus 5? 3 minus 5? Negative 2.
Wait, you don't use the 2 at all?
Oh, the 2. I'm sorry. And there's a 2. Yeah. So what's it going to be on top? It's going to be 10 over
Negative
10 over negative 2, which is what?
Negative 5.
3, negative 5. Thank you. I forgot about the 2. Excellent. Ah, is there a vertical asymptote?
Yes.
At x equals y. Where does that come from? The remaining denominator that has a term in it, part of the denominator is a term, x minus 5. You can't cancel it out. It doesn't cancel. How many types of intercepts are there? Oh, 2. And I clicked on the wrong thing. There are 2 intercepts. X-intercepts are when y is 0. And y-intercepts are when what? X is 0. So which one do you want to do first? Yeah, so if you do y-intercept, you just look at this again. So it's going to be 0 plus 2 over 0 minus 5, which is 2 over negative 5. So what's the point? What is the point? Oh, did I forget the 2 again?
Yeah.
2 times this, so what is it? Negative what? Thank you. So it's going to be 0 comma what?
Negative 4.
Yes. On the other side, you set the whole thing equal to it, but you have 2 times x plus 2. What's the only thing that matters over here? The numerator, because the only way to make a fraction equal 0 is to make the numerator equal 0. So that means x has to be negative 2. So what's the y-intercept? Negative 2 comma 0. There are your 2 intercepts. Ah, so now it gets real fun. You're going to have to evaluate this. Limit as x goes to 5 from what side? The right. What's the simplified function? After you cancel, what are you left with? Mikey, what are you left with after you cancel? What are you left with after you cancel everything out? You cancel the x minus 3, so what's left? 2 times over. Okay, so let's look at this for a sec. What happens to this as x goes to 5 from the right? Well, up here, can you tell me what the numerator goes to? What's 5 plus 2? What's 7 times 2? The numerator gets infinitely close to 14. That's fine. Let's look at the bottom. If you are to the right of 5, are you greater than 5 or less than 5? Greater than 5. What's 5.1 minus 5? 0.1. Is that positive or negative? If you take away a smaller number from a bigger number, you're always going to be left with a. So if I have this number 5, and I keep on getting closer to it from the right, what's the difference? It's always positive, right? But the difference gets what? Smaller. So this is 14 on top. The bottom is a small positive number. What's 14 divided by a really small positive number? 1? No, 14 over 14 would be 1. Oh, no. Come on, you can think about it. What's 14 divided by 1? What's 14 divided by 0.5?
140.
28. It gets bigger. Anything like 14 divided by smaller is going to get huge. So what's this end behavior going to be? Infinity. What's the only thing that changes now? When you do the same limit, 5 from the left, what's the only thing that changes? The top stays what? The top stays, it's going to 14.
Yeah.
But if you're to the left of 5, are you greater than 5 or less than it? Less than it. If you're less than 5, the difference is always going to be negative. So what's the only thing that changes? Instead of infinity, it's going to be? Yeah, because it's going to be 14 over a what? Negative small number. So this is going to be negative infinity. Negative infinity. Does that kind of make sense so far?
Yeah.
So what we're going to do now is you see all this information that's up there? It seems like a lot. Is it a lot of information? Yes, it is. And what did I say is the easy way to make this harder than it is? Try to do it all at once. You try to like graph the whole thing at once. It's like when you do word problems. How many of you try to do write the equation right at the beginning? It's really hard. So first of all, let's look at this. What did we find out what was the first thing A told us? What do we have? What does A tell us? What does it say? Yeah, and it tells us the horizontal asymptote. What is the horizontal asymptote? So you go to 2, which is right here, and make a dotted line. There's your horizontal asymptote. Is that part of the function? Is the asymptote part of the function? No. It's just a guideline. We know it's going to get close to it. Is it going to touch it? Nope. So what do we have next? Oh, a vertical asymptote. There's your vertical asymptote. Should I make it purple? I'll make it blue. Where's the vertical asymptote? So 5 is right about here, I think. So that's x equals 5. And that red one is what? The red one is y equals 2. Okay. Oh, we have some intercepts. Negative 2, 0. That's right about here. You see that point right there? I'm making them big so you can see it. And negative 4/5 is a little bit down. So I'm going to make this a little bigger here. So there's that point and that point. Do you see those 2 points I put up there in red? That right there is negative 2, 0. Oh, and that's too far down, isn't it? Yeah. That should be higher up. Because it's
vertical asymptote 2 is on 6, 9, 5.
What's the vertical asymptote on? Oh, did I put it too far over to the right?
Yeah.
Good catch. So that's a very good catch. So this right here, where should I put that? I should move it over a little bit, right?
Yeah, like
Half a box. Thank you. That's very important. 5 is right about there. Thank you. Okay, there we go. So this is x equals 5. Thank you. So we have 2 points there. Oh, okay, what's that? What else do we have here? Oh, we have the end behavior. We know it goes to 2. So we could actually graph this a little bit. Could we connect those 2 dots? Do you see the 2 dots on there?
Yeah.
They kind of tell us what's it going to have to do. It's going to do that. And what's it going to do going the other direction? It's going to go down. How do we know it goes down? Look. But also look what we found out. What happens as x goes to 5 from the left? Look what it says. What does it go to? Ah, what happens on the other side? It goes to positive infinity, so this is going to go down. Oh, we missed something. What did we not plot? There's a hole, isn't there? Where's the hole? Let's make this, we'll make it blue. There's the hole right there. See the hole? 3, negative 5. Where's 3, negative 5? Right about, oh, we kind of crossed it. Hole. That right there, we're getting full credit. You label the intercepts, the end behavior matches, and it goes there. Yes?
Do you have to cross the hole?
You have to, I don't know. If I had to erase, I would erase it, like I would go to the fine-tune eraser and I would erase that right there. I'm just labeling it. It's a hole right there.
No, but like what if we did like a test or something? Would you want like you want the line to cross the hole?
I would optimally, if you have an eraser, I'd like you to erase inside of it.
Okay.
I would like you to exaggerate the size. I mean, theoretically, how big is a point? It's really, really small. It's one-dimensional. One-dimensional.